Okay, I told you to do the backward pass last time. And once we do the backward pass, we get these values here, which I have written. Your early start and early finishes, all the values as EST and EFTs are written. LST and LFT is also written here. Now this looks very complicated, but there are some different types of keys which are available, which can be used to draw the diagram and put the values at the right location. So I'll also show you one different diagram where the key is different. The node, the way the node is presented, this one. Okay, and I'll just show you now itself. So this one, right? Now, if you look at this, it is the same diagram which I have put here, but the key here is we have a circle, the node, and below this on the right hand side and the left hand side, you can see this is your earliest occurrence, and this is your latest occurrence time. Okay, which can be easily taken from the position from your the arrows which we have drawn before. So doing the forward pass and the backward pass, we can find out the values of EI and LI as well. Okay, you might have gone through the formulas which I have given you previously. Let us continue. Now, if you look at this overall calculation, which we did last time, across the diagram, it is very easy. I'll just show you the example of your forward pass is very easy. I start with 0. Your first node should always start with 0. 0 plus 2 will give me the finish time. Earliest, we can say finishing time for 1, 2 will be 2. Okay, then go ahead. So this event, that is 2, 3, or you can call it as your activity B, will start at 2. 2 plus 3 gives you 5. Here also 2 plus 4 gives you 6. Now this is 5, so here we have the earliest start as 5, both of them. So this is 5 and this is 5 here. 5 plus 5 gives you 10. 5 plus 1 gives you 6. Okay. Now there are two arrows which are merging into this node. So here we have 6 and this is also 6. So there is a tie here. Actually, we are supposed to take the value which is maximum. So because it is same, we have taken 6 back here. So this is 6 here. Okay, and we put 6 here as well. 6 plus 3 gives you 9, whereas 6 plus 2 gives you 8 here. Okay, now the node number 6 have some values here. Now this is your dummy activity which we have added, and 8 and activity, the duration is 0, so this remains 8 here, and this we calculate when we go for the backward pass. Now, if you look at the values, we have 10 here, 9 here, and 8 here. The maximum is 10, and that's the reason why we have put 10 here. Okay, so 6, 7 will start at 10. 10 plus 2 gives you 12. Okay, now let us do the backward pass. When doing the backward pass, we have to start with the value which the last node 7 has finished with, the EFT. The EFT value was 12. So my, you can say LFT will be 12 again. Okay, so 12 minus 2 gives me 10. Now, because we have 10 here, you put 10 here, here, and here. Okay, this is just a single node. Now look at the value for H. H is 0, so 10 minus 0 gives me 10 here. Here we have 10 minus 3 gives you 7, and 10 minus 5 gives you 5. Clear? Now coming to this node, node number 4. Here we have 10, because this is 10 here, we have 10 here. 10 minus 2 gives you 8. Now look at the two values. We have 7 and we have 8 here. Now while going for the backward pass, we are supposed to take the least value or the minimum value among these two values of your latest starting time. Okay, so this is 7 and this 8, least is 7. So here we come and put 7 here. Okay, Similarly, we put 7 here. Whereas when we solve this 7 minus 1 gives you 6. 7 minus 4 gives you 3. Okay. Now look at this node number 3. We have 5 here and we have 6 here. Least is 5. So we put the latest finish time for 2, 3 as 5. Okay, so this is 5. 5 minus 3 gives you 2. Here we have 7. 7 minus 4 gives you 3. The least among 2 and 3 is 2. So I put 2 here. And finally, 2 minus 2 gives you 0. That is how we go backwards. If you have doubts, we are going to still do some few more network diagrams. Okay, you can ask me questions whenever you have doubt. You can put it in the chat or you can unmute yourself and ask me the question. Clear? So while drawing the diagram and doing the calculation, it is, it looks very easy, right? If you are supposed to draw a table, if I have to draw a table, okay, the table is like this here. Now these are my activities. Okay, I put all the activities in the first column here. The duration, EIJ. Then EST is given as same as ESIJ, or you can write it as EI as well. So first we are supposed to find out the EST values. Okay, these are my EST values. Then this is your EFT, and the formula I have written. EFIJ is equal to ESIJ plus TIJ. Okay, this is for your forward pass. For your backward pass, we are first supposed to find out the values of LFT. And your LFT is similar to your LJ. Okay, so LFIJ is equal to LJ. And your EI is also known as your earliest occurrence time for event I, and LJ is known as your latest occurrence time for your event J. Clear? So these are the values, like this value 0, 2, 2, this 2 columns, column number 3 and column number 6, which we have put further here in this diagram which I have shown you, this diagram. Okay, so this is my EI. This is my EI. Okay, and this is my LG. Clear? The earliest occurrence time and your latest occurrence time. Let us see the calculation. Those who have not done the calculation can just take a screenshot or note it down, the calculation which we have done. Okay, how do we get this E1, E2, E2 again? Depends on the activity, the first activity here, the value of I. So if the value of I is 1, this is E1. Here the value, we have 2, 3 and we have 2, 4 as well. So this E2 and E2 again. Okay, so depending on the value of I and J, you are going to do this calculation. Any doubts in this calculation? One more thing. First, this 3 and 4 represents your forward pass, and 6 and 5, because we are supposed to find the value of LJ first. Okay, so when I say LJ, your activity 1 and 2, you can see J, the value of J is 2. So this will be L2. Okay, so first find LFTs, this value, and find the next value of LSIJ. Then again find the value for L3, then find the value for LS, you can say here 2, 3. Okay, this is how you have to go about doing it. I hope there are no doubts here. Now let us go ahead and understand what you mean by critical path. There are two components which we need to know when we are talking about a critical path. The first one is your critical activities, okay? And then we'll talk about the critical path. Now, what are critical activities? Now, certain activities in your project network diagram are called as critical activities because, okay, any delay in their execution causes delay in the completion of your entire project. Okay. Now, what are those activities? How do you find those activities? Now, coming back to the diagram here. Now, if you look at the diagram, wherever your values, your E and you can say earliest occurrence time and your latest occurrence time is same. Okay. Then we say that that particular activity is a critical activity. Okay, we can take an example. Let us take an example here. You can see for this one, the critical activity, the EST, your EI and your LJ is same. Okay, that is 10-10. Or let us not refer this one. Let us refer to the other diagram. This one. Okay. Now all the nodes, okay, where the value of your E and L are same. For example, this one, 12-12, it's a critical activity. Then the activity number 6 here, the node number 6, where we have 10-10. Okay, again, it's critical. So I becomes critical here. Okay, that's why we have put this in double arrow, double line, or you can also put a bold line there with the arrow. The second one, you can see this is the node where the same values are there. The value of E and L is same. Okay, that's why this and this, that is activity E, or you can call it as 3-6, becomes your critical activity. Next one, here we have 2-2. Okay, but here we have 6-7. So this activity C is not critical. Whereas in this case, we have 2-2 here and we have 5-5, same values. So here, this is your critical activity, and finally, this one. And that's the reason we have put these activities, the arrows which we have put is either you can put a double row, double line, or you can bold it, make it bold lines, darker line. Okay, to indicate that it is a critical path. So this path from 1, or you can say A, B, E, I is your critical path. Okay, and the activities 6-7, 3-5, 3-6, 2-3, and 1-2 are your critical activities. Clear? It will become easy for you to find the critical activity using the earliest occurrence time and the latest occurrence time. There's one more method which I'll show you, which is where we do the calculation of all the critical, you can say path, all the paths, we find out all the paths from the network diagram and try to find the total duration. Okay, and the longest duration path having the minimum time, that is not, you cannot say that will be the minimum time which will be required to complete the project. So the longest duration path is nothing but your critical path. Okay, so if you want to find out the critical path without using the forward pass and the backward pass, then the best way is to write all the paths in the network diagram, all the combinations of the path, find the total duration of each of them. The one which is having the longest duration is nothing but your critical path. That's the other method. Okay, so without doing any calculation, you can find out the critical path as well. Okay. Now, as I told you, there are two methods. The first method is for the simple network diagram, where the number of paths are very less. So easily we can, find out the duration for all these paths, and the longest duration will be your critical path. The second one is to compare the value of your earliest occurrence time. If it is equal to the latest occurrence time, then that particular node, okay, will be considered as a part of your critical path. Okay, so either you can also call that node as your critical node, and the activities connecting all these critical nodes, okay, along the critical path will be your critical, along the critical activities will be your critical path, which we have just seen in the previous diagram. Any doubts in finding out the critical path? There are two methods. I'll repeat once again. Without the calculation of your ESTs and your LSTs and so on, what you can do is find out the duration for all the paths which are there in your network diagram. Okay. The path which is having the longest duration will be considered as your critical path. That is the simplest way. If the question given to you asks you to find out the values of your earliest occurrence time and your latest occurrence time, in that case, you have to make use of the forward pass and the backward pass to do all the calculations which we just saw. Okay. And whichever node has the earliest occurrence time equal to the latest occurrence time will be a part of your critical node. Okay. So it will be called as a critical node. And all the critical nodes which are connected, okay, through the activities will form your critical path. Okay. So two methods, whichever method is asked. If there's a simple network diagram asked, then you can use the first method. If the calculations for all the nodes are asked, then please make use of the second method, where we are comparing the earliest occurrence time and the latest occurrence time. As you can see, this is your diagram where we have done the calculation and we have put the values. In the key, we have written the node number, the node 1, and you can, if you see in node number 1, we have the two values 0 and 0. The first 0, that is the lower left part, is your earliest occurrence time, and the lower right part is your latest occurrence time. Okay. Again, these two values are supposed to be found using the forward and the backward pass. And whichever are your critical activities, you can put the double line, okay, with the arrow, or you can bold it, make it bold. That's more than enough to indicate that it's a critical path. Let us see the calculations which can be done and found out. So this is the calculation. These were the all different paths which were available. And if you look at the first path itself, where the total duration, the summation is coming to 12 days. That's the longest duration. And therefore, your A, B, E, and I are the activities falling on the critical path. So if I delay the activity A, B, E, or E, the overall completion duration or completion time of your project will get delayed. That means you have to be very careful while completing or doing your activity A, E, B, E, and I. Okay, you cannot delay these activities. Whereas the other activities like D, C, okay, even if you delay that by some duration, now that some duration, what duration you can delay that? That totally depends on the slack, okay, or it is also known as your floating time. Okay, there are different types of floats which are available and different calculations which are available. And the most important one is your total float. So we are going to see that as well. I'll show you the calculations which are involved while finding out the slacks or the floats for a particular event. I hope this one is clear. So finding critical path is easy, okay? And whenever there is a network diagram, critical path has to be found. And please remember, finding critical path is a part of your CPM, critical path method. Okay. Let us see the next topic where we are going to actually try to find out the different floats, the values, the functions. Understanding this topic, especially how to find out the floats, very important. Okay. So there are questions which are asked based on, you can say, network diagrams where we are supposed to find out the floats and different types of floats for different activities. Basically, as I told you, there are different types of floats available. The first and the most important is your total float. The second one is your free float. And the third one is your independent float. Okay, let us see all of the definitions for floats. Okay, now the event float, or you can say the event slack, okay, of an event. So the float of an event, which is also called as a slack, so the two terms are interchangeable, is nothing but the difference between the latest and your earliest occurrence time. Okay, so Li minus Ei is nothing but the slack of that particular event. A very simple formula. Okay, so the value of Li minus Ei for the event I gives you the slack of that particular event. Okay, it shows the time duration by which the occurrence of that particular event can be delayed without delaying the completion of the entire project. And as I told you, on critical events, the value of Li and Ei is same, it's equal, and therefore the slack is 0. It directly indicates that you cannot delay that particular event. Okay, so wherever the slack or the float value is 0, that particular event cannot be delayed. Next one, your activity float. Your float or slack of an activity is the available time by which its duration can be delayed. Okay, there are three main types of floats, as I told you, which can be found out. The first one is your total float. Now, your total float or total slack is the time duration by which the completion of an activity could be delayed beyond its earliest expected finishing time. Okay, without delaying the overall completion of the entire project. That is nothing but your, you can say the formula is TF. TF is for total float for IJ is given by LFIJ minus EFIJ. Okay, as you know, the float or the slack is always calculated using L minus E. Okay, so when we talk about TFIJ, the calculation will be LFIJ minus EFIJ. Clear? That is your latest finishing time minus your earliest finishing time. Will give you the total slack. The formulas are written in different ways. So there are three formulas. You can, note it down. Okay, all these three formulas where we write TFIJ equal to LFIJ minus EIJ. Now, because we already know the formula for EFIJ, okay, and EFIJ, we can represent that here. Here you can see this. We have included this TIJ here, okay. And when we open this bracket, we can also write LSIJ minus ESIJ. So it is one and the same. Okay. So either you use the finishing time or you can use the starting time. The earliest starting time or the latest starting time can be used. So all these three formulas can be used to do the calculation for your total float. The third formula where we use LJ minus EI minus TIJ. Okay, LJ is your latest finishing time for J. Okay, minus earliest, you can say starting point or finishing point, any one of them. So earliest occurrence time of I minus the duration. Even that will give you the total float for IJ. Clear? Now, there are some points to be noted. Note down all of them. The first point, the last relation is quite useful in calculating the total float once the earliest and the latest event times are known through the forward and the backward pass. Okay, especially the third equation which we saw. Now for the critical activity, your EFT is equal to LFT, okay, and your EST is equal to LST. And therefore the total float will be always 0. If we have a negative value of float, it implies that the resources are inadequate. And so the activity may not be finished in time. Okay, this calls for for providing extra resources or for crashing. Your crashing is known as nothing but shortening or compressing. Now we are going to do crashing. There's a different topic based on crashing. So if we get a negative float value, in that case, we'll be using the technique of crashing so that we can shorten the overall duration of your project, or we can compress it. Okay. Now, zero value of float signifies that the resources are just sufficient for completing the activity and it cannot be delayed. Okay, that is especially the critical activities. Whereas the positive value greater than 0 of float implies that the resources are excessive for the activity so that they can be reallocated or the activity can be delayed accordingly. Okay, so wherever we have total float greater than 0, those activities can be delayed, okay, depending on the requirement. And if it is negative, then we need to go ahead and perform crushing or shortening of that particular activity. Okay, also known as compressing. Now the total float is the most important float, okay, which is concerned with the completion of your total project or the entire project. So whenever we are actually doing the calculation, we'll be more focusing on your total float than the free float and your independent float. Okay, and the last point, it signifies the difference between the total time available for an activity and the time required for its execution. Clear? Let us see the next one, your free float. Now, what is a free float? It is nothing but the time duration by which the completion of an activity can be delayed beyond its earliest expected finishing time. Okay, so here we are talking about the finishing time without delaying the earliest expected starting time. So without delaying the starting point or starting time of an activity. Okay, so we have a formula for this, where we have taken the example of activity Ij, where the free float is written as FFIJ. Okay, it is given by the difference of the minimum of the earliest starting time of all its succeeding activities, starting from its head node J and its earliest finishing time EFIJ. So your formula can be written FFIJ equal to minimum of all your earliest starting of all succeeding activities having tail node minus EFIJ. To understand it better, you can write this formula EJ minus into bracket EI plus EIJ. This can also be written as EJ minus EI minus TIJ. So when we open this bracket, okay, you can write this as FFIJ equal to EJ minus EI minus TIJ. Now all this actually looks very complicated when we are referring to with the names, okay, but when we look at the diagram and do the calculations, it won't be that difficult. Let us see the notes for this particular free float. Okay. Now, in the previous or the slides, we saw the total float, the formula as TFIJ equal to LJ minus EI minus TIJ. Now, if I use this formula and we can represent LJ in the other form, so taking LJ on the other hand side, we can write LJ equal to TFIJ plus EI plus TIJ, right? Now, for any event J, its earliest occurrence time is always less than, please remember, the earliest occurrence time is always less than or equal to the latest occurrence time. That is, your EJ is always less than equal to LJ. Agreed? Using this, we can write this further as EJ less than equal to TFIJ plus EI plus TIJ. Okay. Always remember your free float is less than equal to your total float. Okay, so this can be written like this. EJ minus EI minus TIJ less than equal to total float of IJ. Okay, that itself means that your free float is always less than or equal to your total float. It cannot be greater than your total float. Okay, or your total slack. That's the first condition or first indication of your free float. You need to be knowing it. Next, again making use of your TF, that is your total float formula. We can write this further as your LJ minus EJ in one bracket plus in the other bracket we put EJ minus EI. Now when we open this bracket, what will happen is minus EJ and plus EJ will get cancelled, right? That's why we have just introduced EJ there. Okay. We are trying to come up with a different. This can be written as total float equal to your head event slack, because LJ minus EJ gives you the head event slack, right? And the formula, that is EJ minus EI minus TIJ, is nothing but the formula for your free float. And that's why we can write this as head event slack plus free float. So your total float can be written like this. And if I want to express this in free float term, I can write free float equal to total float minus head slack. Clear? And your head slack is nothing but your LJ minus EJ. LJ minus EJ. I hope you are getting it. Okay, let's go ahead. Now, your free float is concerned with the timely commencement of your succeeding activities. Thus, it does not affect the float of succeeding activities, but can affect those of the previous one. Okay, your previous activities can be affected and not the succeeding activity. Your free float results when all the preceding as well as the succeeding activities start at their earliest event occurrence time. When we talk about earliest, we are talking about the tail event. Okay, we are talking about the tail event. And lastly, it is helpful in rescheduling your project. This is more important point. So it helps in rescheduling the project activities with minimum disruption of the earlier plan or the previous plan without delaying the overall completion of my project. Please remember, without delaying the overall completion of your project. Okay. Now the last float which is available or slack which is available is your independent float. Okay. Now it is the time duration by which the start of an activity can be delayed without delaying the earliest expected starting time of its any independent or immediate succeeding activity. We assume that the preceding activities have finished at their earliest finish time. Okay, so thus if we take the activity ij, its independent float will be given by if ij, and we can found as follows. We can write it, the formulas, you can take it down. Now this is the theoretical part. You can write if equal to minimum available time minus tij. Now what is your minimum available time? Your minimum available time is your early start of all succeeding activities having the tail node j. Okay, if I refer to the tail node, it will be always j, minus the maximum of lf. Lf is your latest finishing time of all your preceding activities having the head node I. Okay, this whole thing, this is the minimum of them, minus tij. If you want to represent this in a better form, you can write ej minus li. Okay, ej minus li minus tij will give you the value of if ij. Okay, so the formula can be further written as ej minus li. Previously, if you remember, we were using lj minus ej. Okay, here we are using ej minus li. Okay, the node, the number changes here. ej minus li. Is represented as the earliest starting time of your preceding activity. You are having the tail node. Okay, and thus we can also write this if ij equal to ej minus li minus tij. Okay, so all these formulas will take some example based on this floats example when we come next. We'll stop here. It's less than 1 minute left. Please revise all these formulas. Thank you, everyone.